All right, everyone, this lesson is for 4.1.1 and it is beyond aircraft. And really, the goal of this lesson is to apply aerospace concepts to alternative applications. So, things that we don't traditionally see as aerospace engineering applications. So, the biggest one that we're going to be looking at is the use of wind turbines. And as you know, wind turbines have really come into vogue in the past like 5 to 10 years all over the world. Wind power is something that is being harnessed far more than some of the other renewables that are out there. As you know, wind turbines harness naturally abundant wind and transform it into electrical energy. The real kicker for wind turbine design is that turbine blades have to efficiently convert the wind energy into a force that turns a wind turbine. So this energy conversion is actually an application of aerospace engineering principles because if you think about it, each of those blades is essentially an airfoil. And we spin that airfoil in a circle to generate electricity. Now, beyond looking at our airfoil concept for wind turbine blades, really we're looking at fluid movement being harnessed for many applications. So wind power is the one we're really going to be focusing on, but also cooling. Okay, anytime we're looking at airflow to try and get cold air to move over warm air, much like weather patterns do, we're looking at the application of how air moves and car profiles. That leads directly to engine efficiency and gasoline consumption and our reliance on foreign oil. So looking at how automobiles are designed to be more low profile and more fuel efficient. We also have water turbines. Water turbines are the concept of basically a wind turbine underwater. It's tidal power. So as a tide comes in and out, that energy and power then generates electricity through the use of that turbine blade. And there are a lot of others too. These are just the big heavy hitters and the most, quote unquote, obvious of the alternative applications. Okay. Also, in addition to that, we've got a lot of spin-off technologies from NASA. So looking at Unit 3, you guys focused on space and all of those things. And one of the biggest things that we have when we look at applications of aerospace technology is the use of fabrics. Okay, we had to figure out how to send stuff into space through our atmosphere and keep it together. Some of those include things like stadium roofs. Any stadium that has like a fabric roof on the Denver airport is also another example of this type of roof, where you've got the Teflon and the Gore-Tex. And then in addition to that, you've got life rafts that are on all major ships, as well as new medicines that we're working on growing in microgravity. So in addition to this, we also have what's called life shears. So those are technology to shear bolts connecting at rocket stages. So this was actually huge with James Webb when they launched it. And one of the reasons it was delayed in its launch was because space junk, when the bolts shear, you then have pieces that are just kind of like hanging out in space. So how do we make them small and shear in a way that's not going to cause damage to other pieces? And then also we now have a heart pump that's based on the electric pump used in the space shuttle that's based on propulsion. Now, rewinding back to wind power, just a little bit of history of wind power. We've been using wind power since like 5000 BCE. It really started with, your very, very early, let's spin a wind-based wheel to get a task done. And then that wind power faded in favor for steam power in the 1930s. We transitioned to steam power that was coal generated. But really, it's coming back as a modern application because our reliance on non-renewable resources is just not something we can depend on. Okay. Now, this chart that you're seeing on this screen is where we can really harness wind power, where the best spots are for it. So anything that is blue is a fantastic area to harness wind power. So off the coast of California, you've got some spots off the East Coast. Red is outstanding. So anything that's really on a coastline, again, the Great Lakes, all of that is outstanding area. Purple is excellent. So you see some more of that in the Gulf area. Pink is good. So that Midwest through the Great Plains is solid. And then that's like middling to fair through there. But really the coasts are where we can harness wind energy. So this is a local thing that can absolutely be used to create and generate electricity. Now, something I do want to point out is this strip that's through here. For any of you that do not know geographically why you're seeing some of the good versus like absolutely nothing like you see in these other areas, this strip that's running down kind of the center of the mid-Atlantic region, those are the Appalachian Mountains. And the Appalachian Mountains have been a hotspot for wind energy in the past several years. And I know this because my mom lives right about there, and there are wind turbines all over the place up there. So really quickly, this video on how a wind turbine works is going to be linked outside of this video. So you can go ahead and watch just to get a general idea of how a wind turbine works and then how that actually applies with aerospace technology. Okay. Now, really, again, the concept of what we're looking at for 4.1.1 is blades as an airfoil. And airfoil blades are aerodynamic shapes, and the aerodynamic engineers design those wind turbine blades. We've even gone as far as using biomimicry, which is the concept of looking at things in nature and applying them, to even look at the fins of blue whales and how they efficiently move through water. To design some wind turbine blades. So really your inspiration for what a wind turbine blade as an airfoil can look like can come from anywhere as long as it's increasing the efficiency of the electricity generated.